Hello everyone, and welcome back to my channel. This is Vishnu Pudi, and I am glad that you are here. Today we will be solving problems 19 and 20 of the 2017 AMC 8. Let's begin with problem 19. For any positive integer m, the notation m factorial denotes the product of the integers 1 through n. What is the largest integer n for which 5 to the n is a factor of the sum 98 factorial plus 99 factorial plus 100 factorial? Now, in problems where you're supposed to find the highest power of a prime that divides a sum, the first thing that we always have to do is factorize the sum. Otherwise, it will be nearly impossible to find the number of factors of 5 in the sum. So, to do this, we note that 99 factorial is 99 multiplied by 98 factorial, since the integers 1 through 99 are just the integers from 1 to 98, with the 99 tacked on. Similarly, 100 factorial is equal to 100 times 99 factorial, which, as we shown earlier, is 100 times 99 times 98 factorial. Thus, we can factorize the desired sum, 98 factorial plus 99 factorial plus 100 factorial, as 98 factorial times 1 plus 99 plus 100 times 99. This is simply equal to 98 factorial multiplied by 10,000. So now we can see that 10,000 is equal to 10 to the 4th, which is equal to 2 to the 4th times 5 to the 4th, meaning that it has 4 factors of 5. Now, all we need to do is find the number of factors of 5 in 98 factorial. To do this, we look at the number of multiples of 5 between 0, 1, and 98 inclusive, because these will be the ones that add to the total number of factors of 5. This is simply 98 divided by 5, and then taking the floor of that. Since we want an integer value that's the greatest integer less than 98 divided by 5. This is equal to 95 divided by 5, or 19. But now we have to think more carefully. If we put in 19 plus 4, or 23, as our answer, we will get this wrong. This is because some numbers have higher powers of 5 than simply 5. These numbers are 25, 50, and 75. We have to add an extra 3 from these numbers because these numbers contribute an extra 1. The number of these things is the floor of 98 over 25, which is simply, as before, equal to 3. Thus, our actual answer is 19 plus 3 plus 4 is equal to 26. Choice D. Note that to make sure we actually got the right answer, you can take the floor of 98 over 125, the next highest power of 5, and see that this is equal to 0, so it does not contribute to the sum. Problem 20. An integer between 1,000 and 9,999 inclusive is chosen at random. What is the probability that is an odd number whose digits are all distinct? First of all, we know that from this range, the number has to be a 4-digit integer. To solve this problem, we will need to use constructive counting. What do I mean by constructive counting? Well, constructive counting is finding the number of ways to do something from following the conditions of that thing. So first of all, let's first reveal the constructive counting approach. We know that probability is equal to success over total. And we know that total is just equal to the number of 4-digit integers, which is just 9 ways for the first digit times 10 ways for the second digit times 10 ways for the third digit times 10 ways for the fourth digit. And this is an application of constructive counting. We basically use the definition of a 4-digit number combined with the fact that the first digit cannot be 0 to get a result. 9 non-zero digits and 10 digits including 0 have allowed us to compute the total as 9,000. And now that we are familiarized with constructive counting, we can take on the much harder task of computing the number of successes. So, the number of successes, well, let's look at the construction. We have 4 digits, and we want the last digit to be odd. That's our highest priority, since it's an odd integer. There are 5 odd digits, so we take there are 5 ways to choose this last number. Let's just say, for example, it's 5, and there's 5 ways. Then we need to choose the first digit, since that's the next most restrictive. Since 0 is not an odd integer, we know that there's 9 minus 1 ways to do this, since there would be 9 ways in general, but you take out the digit that we used here, due to the digits are all distinct condition. 9 minus 1 is simply 8, so we can just put whatever we want. In this case, I'll just put 8. Now, we find the number of ways to choose the middle 2 digits. This is just 8 times 7, since these digits have to be distinct, and we've already used 2 digits of the 10, so this one's going to be 8 ways. I'll just make that a 0, and this one's going to be 7 ways, because that's 10 minus 3. I'll just put it to 7. And we have constructed one of these numbers, and in doing so, we have found the total number of successes, 5 times 8 times 8 times 7. 5 times 8 is 40. 8 times 7 is 56. 56 times 40 is equal to 56 times 4, which is 224, multiplied by an additional 10. So we tack on a 0, giving us a total number of successes of 2,240. The probability is thus 2,240 over 9,000. Canceling out tens, we have that this is equal to 224 over 900. Canceling out a factor of 4 in the numerator and denominator, we have the numerator is equal to 56 divided by the denominator being 225. Choice B, and we are done. Thank you so much for watching this video. It really means a lot. Please don't forget to like, share, and subscribe, as well as click the bell icon. As always, if you have any questions, comments, or concerns, please post them down below, or email at caspirations@gmail.com. This is Vishnu Manjipudi, signing off. Bye!